So I think in the last class we have finished the physical analysis, right? So we have seen many formulas and we also seen the theoretical concepts, right? So first, what is the operation of the diode? So what's happening inside the diode, and what is the formula for depletion layer on P side and N side, and expression for electric field, barrier potential, and all of those things we have seen in the last lecture. So as I said in the earlier class, so in this video lecture, I am going to explain the problems that are related to the physical analysis. Okay, and from the next lecture, I will start the interesting part, which is nothing but DC analysis of diode, which is entirely related to networks. So before coming to the next class, so I advise you to revise all the concepts of networks thoroughly, and then you can attend for the next class. Okay, simply. Fine. So we will see the first problem regarding to the physical analysis of the diode. So you can see the first problem on the screen. So the doping concentration on P side and N side are 1 into 10 power 16 and 1 into 10 power 17. Okay, so simply we have given Na and Nd. So okay, so we have given two donor and acceptor concentration. So the doping concentration on P side is 10 power 16, right? So therefore Na is nothing but 10 power 16. So what is the doping concentration on N side? On N side it is nothing but 10 power 17. Okay, so this is the first part that is given. Okay. Fine. So a forward bias of 0.3 volt is applied to the diode. So forward bias voltage is given, right? So forward bias voltage Vf is equal to 0.3 volts. Okay. So they have given that there is a semiconducting device. So we have acceptor concentration on one side and donor concentration on the other side. And the value of the forward voltage is nothing but 0.3 volts simply. Okay. So next one. At 300 Kelvin, the intrinsic concentration Ni is equal to 1.5 into 10 power 10. Okay. So the intrinsic concentration Ni is equal to 1.5 into 10 power 10. So this is nothing but intrinsic concentration. Okay. After that, and thermal voltage is nothing but 26 millivolts that we already know. The electron concentration at the edge of the depletion layer on P side. This is very, very important. Okay. So this one separate formulas కూడా మనం derive చేసుకున్నాం. So కాబట్టి మీరు వీడియో పాస్ చేసుకొని సో ఏవైతే డేటా ఇచ్చారో దాన్ని అనలైజ్ చేసి మీరు ఆటోమేటిక్ ఈ ప్రాబ్లమ్ కి సొల్యూషన్ ఫైండ్ అవుట్ చేయండి. So what we have asked for? So we have asked for the electron concentration at the edge of the depletion layer on P side. Okay. So let us suppose this is nothing but a PN layer. This is P and this is N. Let us suppose this is nothing but here the depletion bit. And they are asking that when a forward bias voltage is applied over here, so they are asking that what are the concentration of electrons at the edge of the P side. They are asking this one. Okay, so the edge of P side lo any electrons undi ani antunnaru. So we already know that Np is equal to Np naught. Np naught is equal to Np into e power q into Vf upon Kt. Isn't it? Np naught is equal to Np into e power q into Vf upon Kt, right? So Np is nothing but concentration of holes, concentration of electrons on P side. Actually, the P side majority carriers are holes, isn't it? So kabatti holes యొక్క concentration ఎంత ఇచ్చారు 10 power 16. So therefore the concentration of electrons at P side, అంటే దాని meaning ఏంటి? Minority carrier concentration on P side, right? So that is nothing but N suffix P is equal to ఏమవుతుంది? Ni square upon the majority carrier concentration is nothing but Na. So what is Ni square? Ni square is nothing but 1.5 into 10 power 10 chi square divided by Na is nothing but acceptor concentration, right? You will get 10 power 16. So that is equal to 1.5 whole square into 10 power 10 is nothing but 10 power 20 divided by 10 power 16. So this is nothing but the concentration of electrons at the edge of the on the P side. So we need to find what is the value, the concentration of electrons at the edge of the P side, right? So ఇది మీరు చేస్తే 1.5 ఇక్కడ NP is nothing but 1.5 whole square. It is nothing but 2.25 into 10 power 20 by 10 power 16 is nothing but 10 power 4. Okay, so into e power q into Vf upon Kt is nothing but Vf upon Vt, right? So Vf is nothing but 0.3 and Vt is nothing but 26 millivolts. That is nothing but 0.0259 or 0.026 volts. Okay, if you type it in the virtual calculator or an engineering calculator, so definitely you will get the answer. Okay, so this is the formula for the concentration of electrons at the edge of the P side. Okay, so simply the concentration of electrons at the edge of the P side and మిమ్మల్ని అడిగారు simply, right? So దానికి ఆల్రెడీ ఫార్ములా ఉంది Np into e power q into Vf upon Kt. సో అన్ని వాల్యూస్ మనకు నోను, కాకపోతే మనకి Np వాల్యూ ఫైండ్ అవుట్ చేయాలి. Np is nothing but concentration of electrons at the edge of the P side. And initial P side majority carriers holes కాబట్టి it is nothing but Na is 10 power 16 and therefore N suffix P is nothing but Ni square upon Na. Then you can finally get the answer. Okay, so as simple as such. Okay. Yes, you can see the problem on the screen. So here you can see that Np naught is equal to Np into e power q into Vf upon Kt. So ఈ Kt ముందుకు వస్తే Vf upon Vt అవుతుంది. సో ఇక్కడ Np వాల్యూ క్యాలిక్యులేట్ చేయాలి. Np is nothing but Na square upon Na. So 2.25 in 10 power 14 and Np naught is equal to 2.25 in 10 power 4 into e power that value. So automatically మనం ఎంతైతే వస్తుందో అది ఈజీగా మనం సాల్వ్ చేసేసచ్చు. ఓకే, సింపుల్, రైట్? So I'm moving on to the next problem. Yeah, you can see the next problem on the screen, right? So consider a region of silicon devoid of electrons and holes with an ionized layer with a donor density Nd is equal to 10 power 16. That is nothing but donor concentration is 10 power 16. The electric field at x is equal to 0 is 0 volts per second. Very good. So they have given that we have a semiconductor. Okay, so let us erase this one. So we have a p-n junction, let us suppose. So we have P and an N junction. Okay, so they have said that consider a region of silicon divide of electrons. Divide is nothing but device, right? Electrons and holes with an ionized layer with donor concentration Nd is equal to 10 power 7. Okay, so in case of donor, N side, the donor concentration is 10 power 70. So that is given. So Nd is equal to 10 power 70. So that is given per centimeter cube. And after that, the electric field at x is equal to 0 volt per centimeter and x is equal to L is 50 kilovolt, right? So therefore, at x is equal to 0, the electric field is 0, and x is equal to L. He has said that 50. I think it's nothing but 50 kilovolt per centimeter, right? Kilovolt per centimeter. Okay, so and the distance is in. Okay, fine. X is equal to 0 and x is equal to L simply. So that means we can assume it as centimeter, right? So at x is equal to L, the electric field is 50 kilovolt per centimeter, right? So finish. Next one is in positive x direction. Okay, so assuming that electric field intensity in y direction, assuming the electric field is 0 in y and z direction. Okay, so y and z directions electric field is 0 aithe, given that epsilon naught is equal to 8.845 into 10 power minus 14 farad per centimeter, then epsilon r is equal to 11.7. Okay, the relative permittivity is given, and we have asked for the value of L, right? So we have asked for the value of L simply. So therefore, this L is equal to question mark, and actually here, so there will be no P. So they have said that there is no junction. So simply it's a silicon divide. So totally it is a silicon device. And since they have given Nd, it will be an N-type semiconductor, obviously. In this, the minority charge carriers will be whole. So what have they asked for? At 0 centimeter, the electric field intensity is 0. And at L centimeter, the electric field intensity is equal to 50 kilovolt per centimeter. So we have asked for L. So we already know that. So the slope. So since మనకి ఎప్పుడైనా సరే 2 పాయింట్స్ దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఇచ్చేసేసి అన్నోన్ పారామీటర్ కనుక్కోమంటే డెఫినెట్లీ వీ షుడ్ గో ఫర్ స్లోప్, రైట్? సో ఇంజనీరింగ్ మ్యాథమెటిక్స్ మనం చాలా ప్రాబ్లమ్స్ చేసాం వాటి మీద. సో స్లోప్ ఫైండ్ అవుట్ చేస్తే వాట్ ఈ స్లోప్? స్లోప్ ఈజ్ నథింగ్ బట్ డిఈ అపాన్ డిఎక్స్, రైట్? సో డిఈ అపాన్ డిఎక్స్ ఈజ్ ఈక్వల్ టు క్యూ బై ఎప్సిలాన్ ఇంటూ ఎన్డి ఆర్ మైనస్ క్యూ బై ఎప్సిలాన్ ఇంటూ ఎన్ఏ. సో ఏదైనా కానీ ఇక్కడ నేను ఎన్ టైప్ సెమీ కండక్టర్ కాబట్టి ఐ హావ్ టేకెన్ యాజ్ ద ఫస్ట్ కేస్. సో దట్ ఇంప్లైస్ వాట్ ఈస్ డిఈ బై డిఎక్స్? డిఈ బై డిఎక్స్ ఈజ్ నథింగ్ బట్ E2 minus E1 upon x2 minus x1 is equal to q is nothing but 1.6 into 10 power minus 19 divided by epsilon. Epsilon is nothing but epsilon naught into epsilon r. The value of epsilon naught is 8.845 into 10 power minus 14 and 11.7, right? So 8.845 into 10 power minus 14 is epsilon naught into epsilon r is nothing but 11.7. Okay, so this is the thing. What is epsilon 2? Epsilon 2 is nothing but that implies epsilon 2 is nothing but 50 kilovolt per centimeter minus electric field 1 is 0 volt per centimeters by x2 minus x1 is nothing but L minus 0 is nothing but L is equal to 1.6 into 10 power minus 19 upon epsilon, right? So epsilon value we substitute change, that doesn't matter. So that implies we need to find the value of L. So L is equal to the 50 kilo ante entama 10 cube into epsilon is nothing but epsilon naught into epsilon. Epsilon naught icharu, epsilon r icharu, divided by what is this one? 1.6 into 10 power minus 19. So this is nothing but the value of the length in centimeters simply. Okay, so ఇది మీరు క్యాలిక్యులేటర్ లో కొట్టి చూడండి. సో డెఫినెట్ గా మీకు మీ ప్రోగ్రామింగ్ క్యాలిక్యులేటర్ కొట్టినా వర్చువల్ క్యాలిక్యులేటర్ కొట్టినా విల్ డెఫినెట్లీ గెట్ ది ఆన్సర్. ఓకే, సో సింపుల్. ఒక సిలికాన్ డివైస్ ఇచ్చారు, ఎన్డి ఇచ్చారు కాబట్టి ఇట్స్ ఎన్ టైప్ సిలికాన్ డివైస్. సో ఆటోమేటికల్లీ ఇక్కడ మనకి ఈ L0 దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఎంత, ఎల్ దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఎంత అనేది ఎల్ ఫైండ్ అవుట్ చేయమని. సో ఆటోమేటిక్గా మనం స్లోప్ ఫార్మ్ యూస్ చేస్తే ఆటోమేటిక్గా ఎల్ అనేది ఈజీగా వస్తుంది. ఓకే, సో దట్ ఈస్ సింపుల్. So consider that you have seen the problem and you can see the solution over here, right? So here Nd is 10 power 7 and here x is equal to 0 and x is equal to L. So d by dx equal to q epsilon into Nd. You can also use the second formula, okay? But we need to use minus q epsilon into Na, and Na place lo Ni square by Nd call in that case. Okay, so adi konjam it's not recommendable, right? So next E2 minus E1 by x2 minus x1 equal to q epsilon into Nd is nothing but 10 power 17. So here E2 is 550 kilo and E1 is 0 by x2 minus x1 is L minus 0 is equal to this one. So if you substitute the value of L, you will get this one. Okay, so we calculator lo kottna you will definitely get the value. Okay, simple. So you can see the next problem on the screen, right? Yeah. Consider an abrupt p-n junction at T is equal to 300 Kelvin shown in the figure. The depletion width of xn on n side is 0.2 micrometer. Okay, so they have given that xn is 0.2 micrometer, right? xn is equal to first you need to understand the question, right? So they have said that consider an abrupt p-n junction. There is a p-n junction shown in the figure. Okay, I mean you have a figure over here, so that I am drawing here. So we will have a p-n junction over here. So they are saying that this is the p-n junction. ఇది వచ్చేసరికి p side. ఇది మీకు క్లియర్ గా ఇచ్చారు చూడండి, n is far greater than nd. That means it is a p side, and ఇది nd ఇచ్చారు కాబట్టి this is nothing but n side, right? So they have said that the depletion layer on n side, this xn is 0.2 micrometer, and epsilon is given. So directly at the junction, the peak electric field is there simply. Okay, so the peak electric field, this is nothing but p, and this is nothing but n. And if you see the electric field, let us suppose this is the depletion layer. So if you see that depletion layer ఇలా ఉంటుంది electric field curve. ఓకే, సో ఎప్పుడైనా సరే పీ సైడ్ ఏమో డిక్రీజింగ్ స్లోప్ ఉంటుంది, అండ్ ఎన్ సైడ్ వచ్చేసరికి ఇంక్రీజింగ్ స్లోప్ ఉంటుంది. జాగ్రత్తగా గుర్తుపెట్టుకున్నాం. ఒకవేళ వాళ్ళ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ కనుక ఇలా ఇచ్చారు అనుకోండి, ఎక్కడైతే ఇంక్రీజింగ్ స్లోప్ ఉంటుందో అటు ఎన్ సైడ్ అటు ఎన్ ఉన్నట్టు, ఎక్కడైతే డిక్రీజింగ్ స్లోప్ ఉందో అక్కడ పీ ఉన్నట్టు. ఓకే, స్లోప్ ఈస్ వెరీ ఇంపార్టెంట్. ఓకే, సో అందుకే మనం అక్కడ స్లోప్ లో మైనస్ పెడతాం ఇన్ కేస్ ఆఫ్ పీ, అందుకని ఎందుకంటే మనకు నెగిటివ్ స్లోప్ వస్తుంది కాబట్టి. అదే ఇక్కడ పాజిటివ్ స్లోప్ వస్తుంది కాబట్టి మనం డి బై డిఎక్స్ ప్లేస్ లో పాజిటివ్ స్లోప్ ప్లస్ పెడతాం. ఓకే, so therefore, so here they are asking that xn is equal to 0.2 micrometer, and they are asking this peak electric field. And we already know that the formula for electric field is nothing but q by epsilon into nd into xn, లేకపోతే q by epsilon into na into xp. So what xp ఇవ్వలేదు, na ఇవ్వలేదు కాబట్టి we can go for second formula. What is the formula for q? Q is nothing but 1.6 into 10 power minus 19 coulomb by epsilon value is given into nd. What is the value of nd? The nd in the given question is 10 power 18, right? So nd is nothing but 10 power 18 into xn is nothing but 0.2 micrometer. Micrometer in centimeters lo convert cheyandi into 10 power minus 4 centimeters avutundi. So about 0.2 into 10 power minus 4 centimeter. Okay, if you place it in the programming or whatever calculator, you will get the answer. Okay, so that is the formula for electric field. Simple ama question జాగ్రత్తగా అర్థం చేసుకొని మీరు గనుక ఫార్ములాస్ జాగ్రత్తగా అప్లై చేసుకుంటే వెళ్తే EDC is not very tough, right? So you can see here q by epsilon into nd into xn. So q is given, epsilon is given, nd is given, and xn is, everything is given. So you need to find the value of peak electric field. Okay, fine. You can see the next problem. So for a silicon diode with long p and n regions, the acceptor and donor concentration Na and nd is 10 power 16 and 10 power 17 and 10 power 15, right? So they have given that Na is equal to 10 power 17 per centimeter cube, and nd is equal to 10 power 50. That means we have a semiconducting slab, that means junction. Okay, so concentration of this acceptor impurity is 10 power 17 and this donor impurity is 10 power 15. So the lifetime of the electrons in p region and holes in n region, they are saying that the carrier lifetime is 100 microsecond for both of them. The electron and hole diffusion coefficient, that is nothing but dn and dp, okay, are given 49 and 36. Vt is equal to 26 millivolts and Na is 1 into 10 power 10. When forward voltage and 0.208 volts is applied across the diode, the whole current density from P to N is dash. Okay, simply they are asking that the whole current density from P to N, isn't it? So మనకు already తెలుసు what is the whole current, that is forward current, right? So forward current is nothing but I is equal to I naught into e power q into Vf upon Vt, లేకపోతే Vf upon Vt, right? So that is equal to I naught value ఇంకా మనం find out చేయాలి into e power Vf is nothing but forward voltage 0.208 volts, లేకపోతే 208 millivolts by Vt. Vt is nothing but 0.0259 or 0.026. Okay, so we need to, if you know the value of I naught, then definitely we will get the I. But they are saying that what is the whole current density? They are saying current density. That means we need to find the current per area. So therefore it will also become I naught by A. So therefore now the unknown value is nothing but I naught by A. So and we already know that the formula for reverse saturation current is nothing but Q into A into dn by mu n into n, dn by ln into np plus d mu n, right? So dp by mu p into I think dp by mu p into pn, right? So this is nothing but the thing, right? Now if you can see that q, this is nothing but ln, right? Right. So మనం ఇది ఆల్రెడీ చూసాం. ఓకే, కాకపోతే ఇక్కడ అడిగింది చూడండి. సో ద హోల్ కరెంట్ డెన్సిటీ ఇన్ నానో యాంపియర్ పర్ సెంటీమీటర్ స్క్వేర్ ఫ్రమ్ p to n is dash. They are asking only whole current density. So since they are asking whole current density, we can neglect this one. Okay, so automatically we require I naught by A. So take A this side, I naught by A is equal to q into sorry, they are asking p means we need to neglect n, right? So automatically what will be the formula? dp upon lp into pn, right? So we know that q is nothing but 1.6 into 10 power minus 19 coulombs into what is meant by dp. Dp is given in the question, right? Dp is nothing but the diffusion constant of hole to 36 centimeter per square per second, right? So that is nothing but 36. divided by LP. What is diffusion length? L is equal to square root of D into tau, right? So this we have seen in semiconducting physics, right? So this here square root of dep is nothing but 36 into what is the time constant. Time constant is nothing but 100 microsecond. 100 microsecond is nothing but 100 into 10 power minus 6 into P, and P is nothing but concentration of holes on N side. So N side actually majority carriers ND. Me kavalsindi PN. PN and concentration of holes on N side. It is nothing but minority carrier. So therefore Ni square upon ND. Ni square is nothing but they have given 10 power 10, I think so, right? So 10 power 10, right? So 10 power 10. So 10 power 10 whole square divided by NP is nothing but 10 power 17, right? So ND is 10 power 17, yeah, 10 power 15, 10 power 15, right? So 10 power 10 whole square is nothing but 10 power 20 divided by 10 power 15. 10 power 20 divided by 10 power 15 is nothing but 10 power 5 simply. Okay, so all is known here. So therefore we can easily find the value of I naught upon A is equal to some P value. Okay, so you can place in the calculator, you will get the answer. So if you place here, you will get P into e power 0.208 upon 0.025. Okay, P is known and this value is known. Automatically, if you place it in the calculator, you will get the value of whole current density per unit area. So that is very simple. They have directly asked you the forward current, that is I naught into e power q into Vf upon kT. So current density is current per area. We need to find the value of I naught by A. So by using this formula, I can easily find the value of current. Okay, so కాబట్టి ప్రతి ఏ ఫార్ములాని మనం నెగ్లెక్ట్ చేయడానికి లేదు. సో ఎందుకంటే ఎప్పుడు ఏ ఫార్ములా నుంచి ఇస్తాడో మనకు తెలియదు. ఓకే, సో remember all the formulas, right? So here I is equal to I naught into e power this one. So we can see that I naught by A is equal to this one. So automatically you can find the value of J simply. Okay, yeah. You can see the next problem on the screen. So the electric field profile in the depletion of PN junction is in equilibrium is shown in the figure. Which of the following is not true? My electric field profile anta. So let us suppose here you can see that this is the electric field profile. Okay, so if you can say that, so at the junction the electric field will be maximum. ఓకే, ఎటు సైడ్ పి ఎటు సైడ్ ఎన్ ఉంటుంది, ఎక్కడైతే నీకు ఇంక్రీజింగ్ స్లోప్ ఉంటుంది అక్కడ ఎన్ ఉంటుంది, ఎక్కడైతే నీకు డిక్రీజింగ్ స్లోప్ ఉంటుంది అక్కడ పి ఉంటుంది. అంటే లెఫ్ట్ హ్యాండ్ సైడ్ వచ్చేసరికి ఎన్ అండ్ రైట్ హ్యాండ్ సైడ్ వచ్చేసరికి పి. ఓకే, దిస్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్ ఇన్ దిస్ డయాగ్రామ్. ఓకే, ఎక్కడైతే ఇంక్రీజింగ్ స్లోప్ ఉంటుంది అక్కడ ఎన్ సైడ్, ఎక్కడైతే డిక్రీజింగ్ స్లోప్ ఉంటుంది అక్కడ పి సైడ్. ఓకే, సో దట్ ఈస్ గివెన్. సో ద ఎలక్ట్రిక్ ఫీల్డ్ ప్రొఫైల్ అండ్ ద డిప్లీషన్ ఆఫ్ ఈస్ గివెన్. సో విచ్ ఆఫ్ ది ఫాలోయింగ్ ఈస్ నాట్ ట్రూ? ఓకే, దే ఆర్ ఆస్కింగ్ దట్ విచ్ ఆఫ్ ది ఫాలోయింగ్ ఈస్ నాట్ ట్రూ. So you can see that the left hand side is n and right hand side is p. Obviously that is true, right? So since it is so చాలా మంది ఇది తప్పు పెట్టేస్తారు, ఎందుకంటే ఎప్పుడైనా లెఫ్ట్ హ్యాండ్ సైడ్ p, రైట్ హ్యాండ్ సైడ్ n ఉంటుంది కాబట్టి it is wrong అని పెడతారు. Okay, but it is wrong. Why? Since in the left hand side the slope is increasing, so therefore it is nothing but n side, and since the right hand side the slope is decreasing, so it will be p side, right? So the left hand side is n and the right is nothing but p. Next, the potential difference is 700 millivolts, right? So potential difference you can see over here. What is the potential difference? Potential difference is nothing but double V naught. V naught is equal to 1 by 2 into E into W, isn't it or not? So 1 by 2 into E is nothing but electric field. Electric field into 10 power 4 into what is the depletion width? 1 minus of minus 0.1. It is nothing but 1.5 micrometer. In terms of centimeter, it will be 10 power 4. It will cancel with each other. 1 by 2 into 1.1 is nothing but 0. This will be 0.5. 0.55 is the depletion width. That is nothing but 550 millivolts. This is the barrier potential, but they have given that barrier potential is 700 millivolts. So obviously this option B is obviously a wrong answer. Okay, simply. So next one is both P and N are uniformly doped. Obviously, it's since it is in equilibrium, so definitely it will be uniformly doped. Okay, ఎప్పుడైనా గుర్తుపెట్టుకున్నామా, యూనిఫామ్ గా డోప్ లేకపోతే సో మీకు అసలు ఎప్పుడు అది థర్మల్ స్టెబిలిటీలో ఉండదు. ఓకే, సో యూనిఫామ్ గానే డోప్ చేస్తారు, వాడు చెప్పినా చెప్పకపోయినా దట్ ఈస్ మ్యాండేటరీ. ఓకే, next none. Okay, so automatically option B is the wrong answer, and you can see it on the screen, right? So next one, next problem, you can see it. So the donor and the acceptor impurities of an abrupt PN junction diode are 1.6 and 1.8. So you can see over here. So simply donor ND is equal to 10 power 16 and acceptor concentration Na is equal to 5 into 10 power 18. Okay, this is given. So assuming that Na is 1.5 and 10 power 10 and temperature at room temperature and Vt is 26 millivolts, we know, and epsilon f is given. So the built-in potential and the depletion layer, the depletion width under equilibrium condition. What is built-in potential? V naught is equal to, we know that 1 by 2 into E into W, but we don't know E here, right? మనకి ఇక్కడ E తెలియదు కదా, W అంటే ఫైండ్ అవుట్ చేయొచ్చు by using the formula. Square root of 2 epsilon by Q formula use చేసి we can find. కానీ ఇక్కడ ఎక్కడ మనకి ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ మెన్షన్ చేయలేదు, కొన్ని పొటెన్షియల్ డిస్టెన్స్ కూడా మెన్షన్ చేయలేదు మన ఎలక్ట్రిక్ ఫీల్డ్ ఫైండ్ అవుట్ చేయడానికి. సో మనం ఇంకా మనకి ఏం ఫైండ్ అవుట్ చేయొచ్చు, ఇనిషియల్ ఫామ్ లో తీసుకోవచ్చు. V naught is equal to Vt into ln of Na ND upon Ni square. This is the initial formula. Vt is nothing but room temperature, that is nothing but 26 milli, that is 0.026 into ln of Na is given, right? So 10 power 16 into 5 into 10 power 18 divided by Na square. Na square is nothing but 1.5 into 10 power 10 ka square. Okay, simply. Okay, so if you place it in the calculator, you will get the value for depletion bit simply V0, right? So మనకి Na ఉంది, Nd ఉంది, and at the same time Ni ఉంది కాబట్టి ఆటోమేటిక్గా మనం V0 equal 1/2 into E into W. యాక్చువల్లీ EW ఉంటే 1/2 EW బెస్ట్ ఫార్ములా అవుతుంది, ఎందుకంటే క్యాలిక్యులేషన్ తక్కువ ఉంటుంది కాబట్టి. ఇక్కడ మీకు ఎక్కడ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ గురించి ఇన్ఫర్మేషన్ లేదు కాబట్టి then we will go for basic formula Vt into ln of Na Nd by Na square. If you place all the values, definitely you will get the value of barrier potential, right? Next, the another thing you have asked for is depletion width. Depletion width is nothing but W, right? So W is equal to, what is the formula? Square root of 2 epsilon upon Q into 1 by Na plus 1 by Nd into V0, isn't it? So epsilon is given 1.04 into 10 power minus 12 farad per centimeter by Q. Q is nothing but 1.6 into 10 power minus 19 by Na. Na is nothing but 10 power 5 into 10 power 18, and 1 by Nd is nothing but 10 power 16, and V0 we have calculated before, right? So if you substitute all the values, you will definitely get the value of depletion width. Okay, so question జాగ్రత్తగా చదివి ఏ ఫార్ములా అప్లికబుల్ అవుతుందని చూసుకుంటే so EDC will be very easy. Okay, so especially the physical analysis. Yeah, you can see this one, V0 is equal to dash, that is square root of 2 epsilon by Q into this one. Okay, so we can easily find it. So next one, when a silicon diode having Na and Nd, the total depletion layer width. Okay, so you can see that Na and Nd are given. Na is 9 10 power 16 and Nd is 10 power 16. And total depleted width is 3 micrometer and epsilon is given. So the depletion width on P side and the maximum electric field. We need to find the value of Xp, depletion width on P side. We already know that what is the formula? W into Nd upon Na plus Nd. We have seen already this formula, right? So W, what is meant by W? It is given 3 micrometer. In terms of centimeter, 3 into 10 power minus 4 into Nd. What is Nd? Nd is nothing but 10 power 16 upon Na plus Nd is nothing but 10 power 16 plus 9 into 10 power 16. You will get 10 into 10 power 16. 10 power 16, 10 power 16 cancel out with each other. So 3 into 10 power minus 4 into 1 upon 10. It will become 0.3 into 10 power minus 4. So if you write in micrometer, so 10 power minus 2 upon 10 power minus 2, you will get 30 micrometer. Okay, this is nothing but the depletion layer width. Okay, wait for a second. So total depletion layer width is 3 micrometer. So 3 into 10 power minus 4 centimeter simply. Okay, fine, 30 micrometer. That is 3 in 10 power minus 4 centimeter. Okay, into Nd. Nd is nothing but what? 10 power 16 upon 9 into 10 power 16 plus 10 power 16, 10 into 10 power 16. It cancels with each other. So automatically you will get 3 upon 10, 0.3 into 10 power minus 4 centimeter. So you can leave it like this. So automatically Xp is equal to 0.3 centimeters simply. Okay. So this is 0.3 centimeters. Wait for a while. Here you have got 3 into 10 power minus 4 into 1 upon 10, right? So I am writing here 3 upon 10 is nothing but 0.3 into 10 power minus 4. Okay, so this is the width. So therefore, the depletion layer width on P side Xp is equal to 0.3 into 10 power minus 4 centimeter. Okay, so this is the depletion width. Okay, fine. Next, you need to think that, and also we need to find the maximum electric field. What is the formula for maximum electric field? Maximum electric field E is equal to, what will be the value? We will have Q by epsilon into Nd into Xn or Na into Xp. We have already find Xp, right? So kabatti man automatically Na into Xp formula select chesukochu. Q is nothing but 1.6 in 10 power minus 19 and epsilon is 1.04 in 10 power minus 12, and Na is accepted concentration, which is given 9 in 10 power 16, and Xp we have already found. So automatically if you substitute everything, you will get the maximum electric field intensity. Okay, if we can see here. So 3 in 10 power 16 upon, you will get 10 power, this is 16 upon 16. Okay, if you cancel out this one, so if you can see this one, so this will be 10 power 16 upon 10 into 10 power 16. So this will cancel out with each other. You will get 0.3 into 10 power minus 6. So that is nothing but 0.3 micrometer. So therefore, the value for Xp is equal to 0.3 micrometer simply. Okay, fine. Let's move on. Electric field intensity is nothing but Q by epsilon into Na into Xp is the automatic అయిపోతుంది. Okay. So let's see the last problem for today's session. So then we will close it up. And from the next lecture, I am going to start the DC analysis of diode. Okay, so very simple thing. So networks to link ayi untadi. So which will be very interesting. సో మీరు నెట్వర్క్స్ ఆఫ్ కాన్సెప్ట్స్ అన్ని ముఖ్యంగా KCL, KVL, మెష్ అండ్ నోడల్ అనేది కొంచెం జాగ్రత్తగా రివిజన్ చేసుకుంటే so definitely it will be very easier for you. Okay, so you can see that an n+n silicon device, that is nothing but we have a junction. On the left hand side we have n, on the right hand side also we have n. Okay, so we will have nd1 equal 10 power 18 and nd2 is equal 10 power 15. They are asking for built-in potential. Okay, so I have clearly mentioned you the formula. V0 is equal to Vt into ln of nd by ni square. Actually ఇక్కడ రెండు nd ఉన్నాయి కాబట్టి nd1 into nd2 by ni square వేయకూడదు, అది ఆల్రెడీ నేను మీకు చెప్పాను, రైట్? సో nd1 upon nd2. Vt is nothing but 0.026 into ln of nd1 is nothing but 10 power 18 upon nd2 is nothing but 10 power 15. Okay, so you'll get 0.02 into ln of 10 cube, right? So మనకి ఎంత అయితే వస్తుందో అంత ఒక క్యాలిక్యులేటర్ లో ప్లేస్ చేస్తే you'll get the value. Okay, fine. You can see this one, V0 is equal to 26 and 10 power minus 3 into this one, and if you place in the calculator definitely you will get the answer. Okay, so fine. I think you have understand about the physical analysis, right? So first we need to understand the operation of the diode, and we need to understand, you need to read all the formulas regarding to the physical analysis of diode. And if you solve all these models that I have mentioned for you, so definitely any problem regarding physical analysis of the diode, you can easily solve it. Okay, so from the next lecture, I am going to start a DC analysis of diode. So get ready for that. So be prepared with your network basics. So we'll meet in the next lecture with the DC analysis of diode. So until then, take care and bye.